Hey guys, so today we're going to be doing an experiment that covers the concept of density, but we are going to be using this experiment to explain the scientific method, which is a useful concept that will come into play on pretty much every experiment. So I'm going to explain the scientific method first, then I will go through the experiment, kind of pointing out when each step takes place, and then afterwards I'll explain a little bit about density and the chemistry behind the experiment. The scientific method is a 6-step process that every good scientist is going to use when trying to make new scientific discoveries. So the first step is to make an observation. So this step happens outside of a laboratory, and it can be literally anything that a scientist might notice. The next step is to ask a question. So this question is going to be related to the observation, and it can be related to anything that the scientist is curious about and is willing to test. So the next step is going to be to form a hypothesis. So the important thing about this is that it's going to be an if-then statement, so not a question, that is testable and related to the question. So like if the observation was seeing a can float in water, then the question would be, why does that can float in water? Then the hypothesis might be something related to that, like if I put this can in water, then it will float. So the fourth step is to design an experiment. So this is going to be based completely on the hypothesis, and it's going to comprise of at least one independent variable, which is whatever you're going to be changing from trial to trial, and a dependent variable, at least one, which is going to be what you're measuring, which is important because that is the fifth step, to record the observations of the experiment. And it's pretty self-explanatory, but it's pretty important too, because there's no real point in doing an experiment if you don't have anything to show for it. And then finally, you're going to conclude. So this means you're going to determine the validity of your hypothesis, so whether or not it was a good hypothesis, if you were right or wrong. And you're also going to determine if this merits more experiments, as in if you didn't get enough information from this experiment, maybe it was poorly designed or poorly executed, then this conclusion will help you determine whether or not you need to do more research before making up your mind on the matter. Okay, so now that we've kind of walked through the scientific method, I'm going to apply it to an experiment. So step one is to make an observation. So the observation I'm going to make is seeing this can floating in this container of water. So step two is going to be to ask a question related to the observation. So the question I'm going to ask is, why does this can float in the water? The next step, the third one, is going to be to form a hypothesis related to the observation and the question. So the hypothesis I'm going to ask is, if this can floats, then all cans float. So I'm now going to design an experiment around this observation. So got a couple of other cans right here, and I'm going to use them to test my hypothesis. So now we are going to test the hypothesis by seeing if the other cans float. So I'm just going to take the Diet Dr. Pepper out and put this can of ginger ale in. So I'm putting it in sideways so there are no air bubbles under the can. It's floating all on its own. So far the hypothesis is holding up. I'm going to take this one out and try the regular Dr. Pepper next. So again, no air bubbles. Just going to put it in. Would you look at that? So that one's sunk. So that's unfortunate in the sense that my hypothesis was incorrect, but ultimately that doesn't really affect the results, and it was a well thought out experiment in the sense that it was testable and I got quantifiable results. So I've recorded my observations by videoing the experiment, and in conclusion, my hypothesis was wrong, but I don't think I need any other further research. The experiment we just performed was one designed to test the density of the different cans. So for those who don't know, density can be described as mass over volume, which basically means for any set volume, every substance has a certain amount of particles in it that have a certain weight. And depending on the weight of those particles and the amount of particles in that volume, it will affect the density. And the more dense an object, the more likely it is to sink in water. So that means that Dr. Pepper was denser than the other two because these two floated and this one sunk. So the reason the Dr. Pepper sunk was because its density is higher than that of water's. So water was able to support the first two because these two objects are less dense than the water. But Dr. Pepper was denser than the water, and so the water was unable to support Dr. Pepper, so it sunk. And the reason Dr. Pepper is denser is actually because it has significantly more sugar than the other two. So the Dr. Pepper has 24 grams of total sugars, whereas the ginger ale only has 20 grams of sugar, and the Diet Dr. Pepper has 0 grams of sugar. So that extra sugar was enough to put Dr. Pepper over the edge and make it sink despite the cans all being the same size. And I also brought a different can, this one right here, to kind of exemplify the difference between density and volume and weight and kind of show that they're all different. So this one sunk, this one will not, okay? And even though this one is bigger and it weighs more, it's not going to sink because it is spread out over a larger area, which means it has a higher volume and its density is still lower than that of water despite it being bigger. So that kind of shows that all of those different terms are similar but unrelated, and you're going to have to test the density and not just base things off of their size or weight for that matter.